Hi everybody, we are going to be talking about 18.2.1 in this video, Introduction to Logarithmic Functions. Don't panic. I know some people are like, oh my gosh, we're talking about logarithms. It's not a big deal. I want you to start thinking about logs as just an exponent because that's what it is. We're going to talk about that today. Like, how in the world is it just an exponent? Well, let's find out. So just like multiplication is the opposite mathematical operation of division, a logarithm is the opposite, here's a good word for you, of exponentiation. Exponentiation. When you need to find the exponent. Remember what I just said about it being an exponent? That's what we're doing here. In short, a logarithm is, what do you think it's going to go on that blank? In short, a logarithm is an exponent. Fill it in. Okay, more formally, a logarithm is a calculation in which the exponent, which we're going to call y in our formula here in a minute, is found. When given b and x in the equation, x equals b to the y. Thus, the exponent becomes the output rather than the input. Some of you might be like, what is she talking about? What I'm talking about is that when we get ready to go and graph these guys, and we're going to do this sometime in this video, it's going to be -2, -1, 0, 1, and 2. And when we plug those inputs in, it's actually going in for the y this time. And so that's how it's going to be kind of like your output because it's your y value. And then the result is going to be this x, which is going to be an input. And I know that's a little bit strange, but we're going to practice that a bunch today when we get ready to do some graphing. And I actually don't know if that's going to be this video or the next video, but it's coming. Then the corresponding notation to this is going to be log base b of x equals y. So that's our corresponding notation. So the logarithm of x in base b is written log base b of x, or log base b of x, and is defined as, here we go, log base b of x equals y, if and only if b to the y equals x, where x has to be greater than 0. So look at where x is located. X has got to be greater than 0. So right here, that piece right there called our argument, it has got to be greater than 0. It has to be positive or greater than 0. And B, guess what? Also has to be greater than 0. This also has to be positive or greater than 0. Same thing with here. And B cannot equal 1. So that's even going back to what we were doing in our exponential notation when we were looking at our exponential functions. Remember how we talked about how the base has to be greater than 0 and it can't equal 1. So that's still going to be true for logs. So in other words, our log base b of x asks the question, what power should b be raised to in order to give me x? So here is our log base b of x equals y. And again, it asks the question, b raised to what power is going to give me x? So that's what it's asking me. So again, I'm going to say that again. B raised to what power is going to give me x? And that's why you need to think about logs as just being an exponent, because that's the question it's asking. It's saying b raised to what power is going to give me x? So for example, let's say we had this like that. If we had log base 2 of 8, and so it's asking you 2 to what power is going to give me 8? So 2 to what power is going to give me 8? X equals 3. That's what it is. And so what that means is that log base 2 of 8, that equals, this log base 2 of 8 equals 3, because that's what it is. It's an exponent, right? Logs are exponents. All right, so the other thing I want to put in here, so we're going to put in some definitions for these things. So this b is our base. The x is going to be our argument. And the y is going to be our exponent. Or it's our log, right? All right, so here's our color-coded version. I don't know if I have enough colors on my palette here. So we've got log, and I'm going to do b of, oh, look at that, of x equals y. And then that also means we're going to color code it to go back with b to the y. I'm going to have to keep changing up my colors here. B to the y equals x. So b to the y equals x. So that's kind of color coding it for how these two equations relate, because they're just inverse operations of each other. So just like addition, subtraction are inverse operations of each other, again, exponentiation and taking a logarithm are inverse operations of one another. All right, so based on what's given to you, what I want you to do in these next examples, we're going to convert. So that's all we're doing right now, is we're converting the following equations into either exponential or logarithmic form. So that's all I want you practicing right now, is that we're just, if I give you the exponential form, you're going to convert it into log form. If I give you it in log form, you're going to convert it back into exponential form. So we're just going to be going back and forth between these two forms right now. So for our first example, if we've got log base 3 of 9 and that equals 2, right? That makes sense because we're saying 3 to the second power gives me 9. So log base 3 of 9 is 2. How do I rewrite that? So I want you again to think about what's our base in our log, because remember, in an exponent we have a base and it's raised to an exponent. So what's our base in our log form? It's 3. So it's going to be 3 and it's raised to the exponent. What's the exponent? It's 2, and that equals 9. I've heard some people call this the rule of sevens too. There's no reason why it's called a 7 other than it kind of looks like a weird 7. But here, if you go like this, 3 to the second equals 9. So like what I did, I guess that sort of looks like a 7, but I've heard people call that's the rule of sevens. So whatever, if you want to use rule of sevens, go for it. Number 2, log base 4 of 1/16 is equal to -2. Hey, let's use the rule of sevens. Okay, 4 to the -2 equals equals 1/16. Does that make sense? 4 to the -2, does that equal 1/16? Yep, it sure does. You can also say from up here, what's the base? What's the exponent? And that equals our argument. All right, next example, number 3. This time I'm giving you it in exponential form, is equal 125. All right, so write your log, say log. Okay, we're gonna have a little number that goes here, that's gonna be our base. Fill in your base. What is it? It should be 5. This is your base. This is your exponent. This is going to be your argument, right? So here, we're going to do the 5 here as our base. The 3 comes over here to this side. The 125 comes over here to this side, and it's going to be 125. So it's going to be log base 5 of 125 equals 3. And then do your rule of sevens to double check it. Does 5 to the third power equal 125? Is that what I started with? Yes. So your final answer on that one would be log base 5 of 125 equals 3. And that would be your answer. we're gonna do some more examples. Oh yeah. Number 4, we have log base 3 of 1 over 81, and that is gonna equal -4. So then switch it up. I want you to go ahead and change it into exponential form. Change it into exponential form. What do you get? Write it down. Should be 3 to the 4th equals 1 over 81. So again, here's your base. So put your base in your exponential form. What's the exponent? It's over here. To the -4th equals our argument, which is 1 over 81. There's your answer. Number 5. 10 to the -3 equals 1 over 1,000. I want you to try that one. See what you get. Try that one on your own. Circling it. I've got a tricky one for you. We can totally handle it though. Number 6, we have the square root of 49. Square root of 49. Don't just say 7. Square root of 49. We're not going to write it as, like, we're not going to convert it into 7. But here's our problem we're going to start with. Square root of 49 equals 7. And then we have to convert it into our log form. So I want you to think about how we can convert square roots into exponents. And you may not have heard this before, so this might be new information for you. But we can convert square roots into exponents by thinking about what is our radicand, what's the exponent on our radicand, and it's a 1 because there's no exponent there, so it's an implied 1. And then knowing that our index is 2. And so we can rewrite this as 49 to the 1/2 power equals 7. And you should try that in your calculator. Try that, like put this in your calculator. 49 raised to, you could even do like 0.5 power, or raised to the 1/2 power. And what do you get? You should get back 7, because what your calculator is doing is you're taking the square root of it. All right, so now that we've got it in this form, convert it into log form. So it's going to be log base 49. The 7 comes over here. The 1/2 comes on this side. So that looks totally messy, and it's going to be log of 49, or log base 49 of 7 equals 1/2. And that's going to be your answer right here. So what I want to talk about for another moment is, let's just say, and I'm just going to make up some numbers. I want to talk about what just happened in number 6 for a moment. So let's say we had something that was like 9 squared, and it was raised to the 3rd power, or not raised to the 3rd power. It's 9 squared, and we're taking the 3rd root. How do we rewrite that with 9 being raised to an exponent? We would write that by saying 9 to the 2/3 power is how we would do that. So I just want to talk about that just for a moment to say, if we have other problems like that, we can rewrite it similarly to that. Or if we had 100, the square root of 100, how could we rewrite that raised to an exponent? It would be 10 to the 1/2 power. Because again, the exponent on the 100 is 1, our index is 2. And so the power here, or the exponent of our 100, is the numerator of our fraction. And then the index here of 2 is going to be the denominator of our fraction on our exponent. So I just want to talk about that just for a second, in case some of you had some follow-up questions. All right, so on the back now, we are looking at solving the following logarithmic equations. So we're going to look at solving them, and this one is going to be 4 equals log base 5 of x. So 4 equals log base 5 of x. So what I want you to do is to put it into exponential form. So convert into exponential form. If you want to, some students get tripped up by this because they're used to seeing it like this. If you need to switch it around like that, go for it. Use your rule of 7s. So it's going to be 5 to the 4 equals x. 5 to the 4 equals x. Now in your calculator, go ahead and take 5 to the 4th, and you should be getting 625 for that one. Then you can always check yourself. Does that make sense? Log base 5 of 625, what does that equal? So you're asking yourself the question, 5 to what power equals 625? And the answer that we started with was 4. Does that make sense? 5 to the 4th equals 625. Is that true? You can check it, and it's true. Yes, that's correct. So then our second one, let's try log base b of 64 equals 3. So try that one. Log base b of 64 equals 3. So go ahead and let's put our rule of sevens. Let's do b to the 3rd equals 64. So you are more than welcome to do guess and check on this one. You could say 2 to the 3rd, 3 to the 3rd, 4 to the 3rd, 5 to the 3rd. Which one's going to give you 64? I don't like guess and check. I just like to know how to do it. So I'm going to tell you to undo that cubed root. And we're going to talk about this for a second. How do we undo our squared root like that? You take this, or I just told you the answer. How do we undo this when we have b squared? You take the square root. So we would get b equals plus or minus 8, right? So just like this, b squared equals 100. How do we undo that exponent? That exponent of 2, you take the square root, just like over here. So here, what that means is we're going to take not the square root, because that's not our exponent. We're going to take the cubed root. It has to match. So we're going to take the cubed root, and we're going to get b equals 4 for that one. And because we're taking an odd root, our number here is just going to be positive 4. It's not going to be negative. It's not going to be like plus or minus 4. It's just going to be 4. And then you can check that. You can say, does that make sense for log base 4 of 64? And you should ask yourself, well, 4 to what power is going to give me 64? And the answer is 3. So we did that right. Number 3. Number 3 is log base 5 of 125 equals y. So again, on this one, if you want to, you can do some guess and check. Some of you might already know. You're like, well, that's 5 to the 3rd, because 5 to the 3rd is going to give me 125. Because that's what you can do if you'd like. You can do 5 to the 3rd equals 125. And then if you were doing this and you were showing your work, or 5, sorry. Let's put the 3rd there. That should be a y. So if you were doing this, you would just show me that you're trying, okay, 5 squared, 5 to the 3rd, 5 to the 4th, and you would find out that 5 to the 3rd is 125. So then that would be your answer. So your y would be 3. Well, what I'm going to do is I'm going to give you what's called the change of base rule that's going to help you do these problems, and you don't have to do guess and check. And this actually comes in a day or two, but I'm going to give it to you early. Because why would we want to do guess and check when we have a method to figure it out? So this is our change of base rule. The change of base rule says that if we have something like this, if we have log of 5, a log base 5 of 125. So what you're going to find out is that you have a button on your calculator. This calculator has it on there too. You have the little log button that's up here on this calculator. Well, the log button is automatically log base 10. Well, if you look at what we have here, we don't have a base 10, we have a base 5. So we need to change this in order for it to be a base that we can put in our calculator. So what it says we can do is that we can do log of 125. And what that means is that we're changing it so that the base will be the same. So this will be like log base 10. And then it's going to be log over 5. Okay, so we've got, again, what we're doing. If we did like log base 2 of 8 again, if we were doing our change of base, it would be log of 8 divided by log of 2. So then in your calculator, at least in these calculators, you have to be super careful how you're plugging it in, because otherwise you're going to get the wrong answer. So on my calculator, let's say I'm plugging in this top one. First, I would do 125, and then I'm going to hit the log button. And it gives me like 2.0969, blah, 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 keeps going. Then I'm going to do divided by, and then I'm going to hit the 5, and then I'm going to hit the log button. And then in my calculator right now, it's actually giving me the log of 5, which is not my answer. So then I have to hit equals, and then I get the number 3 on there, which is the answer for this. So again, let's try this one in your calculator because we know what the answer should be. The answer should be 3. So on this one, we're going to do, I'm going to hit 8 and then the log button, and I get 0.90308, blah, 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 divided by 2 log equals, and then I get 3, and then I get the right answer. So make sure that that's coming out right in your calculator. Your calculator is going to be different possibly than mine. But here's your change of base rule that works anytime we have this situation right here. So remember how we started with this, and we're saying log base 5 of 125. Let's just use our change of base formula and figure it out and stop doing guess and check. All right, let's do another problem. We're going to do problem 4. And problem 4 is going to be log base 2 of x equals 4. So let's figure that one out. It's going to be 2 to the 4 equals x. So 2 to the 4 equals x. 2 to the 4th is going to end up giving us 16, right? So we've got that for our answer. Number 5. We've got log base 2 of x equals 4. So log base 2 of x, oh, that's one we just did, I'm sorry. I'm struggling today. I was like, wait a second, didn't we just do that? Yes, we did. All right, sorry guys. 3 equals log base b of 512. Log base b of 512. All right, so this one, if you want, you can rewrite it. If you want to switch it around and do log base b of 512 equals 3. So it's going to be b to the 3rd equals 512. How did I tell you how to solve this a little bit ago? When we have b to the 3rd and it equals 512? Well, how are we going to undo that exponent? I'm hoping you're saying take the cubed root. Because if you're saying that, that would be correct. So we're going to take the cubed root, and b equals 8. All right, we have a few more examples. I'm kind of running out of space here. All right, so let's do, this is discover a log rule. All right, I'm going to try to squeeze it in here. So discover a log rule. It's going to come in handy. All right, so let's say we have something that is log base 2 of 2 equals y. So log base 2 of 2 equals y. 2 to what power is going to give me 2? So the question again is 2 to what power is going to give me 2? And I hope you say 1, because that would be correct. Y equals 1. So the next one, log base, let's do 4 of 4. Log base 4 of 4 equals y. So log base 4 of 4, 4 to what power is going to give me 4? And again, I hope you say y equals 1, right? Because 4 to the 1st power will give you 4. So what our rule states is that our rule states that if you have, here's our rule, I need my red pen. If I have log base b of b, if these match log base b of b, 100% of the time, it's going to equal 1. So log base b of b is going to equal 1, right? Because b to the 1st power is going to equal what? B. That's our rule. Our next rule that we're going to discover, so discover a log rule. is going to be log base 2 of 1 equals y, which asks the question 2 to what power is going to equal 1? 2 to what power is going to equal 1? And I hope you say y equals 0, because that would be correct. Y equals 0. So then if I did log base 151 of 1 equals y. So 151 to what power? 151 to what power is going to equal 1? And you should say y is equal to 0, because that would be correct. So that means our rule here states that if we have log base b of 1, log base b of 1, that is 100% of the time going to equal 0. So here's your rule for that one, for that scenario. And again, the reason why is because b to the 0 power is going to equal 1. And there's your other rule right there. So I am going to leave you with one more question that I would like for you to finish on your own. Oh, let's do purple. All right. This is one I want you to try on your own. So number 8, it says, which pair of solutions is not equivalent? Which pair of solutions is not equivalent? A. Let's give you this one. We've got log base 2 of 16 equals 4, and 4 squared equals 16. Letter B. Is it log base 2 of 0.25 equals -2, and 2 to the negative second power equals 0.25? Letter C. 3 to the 4th equals 81, and log base 3 of 81 equals 4. And D states 5 to the negative 1 equals 1/5, and log base 5 of 0.2 equals -1. So I want you, again, the question is, which pair of solutions is not equivalent? So you should find one of those sets of pairs, so A, B, C, or D, are not equivalent to one another when you're converting them from log form back to exponential form, back to log form. One of them is not equivalent. So I want you to figure out which one it is and why, and report to me the next day in class. Okay, so that's it for this video, because I'm splitting this topic into 2 parts. So this is part 1 of this topic, and then I'll record another video later for part 2 of this topic. Thanks for tuning in.